Welcome to our channel. In this session, we will move to the concept of state space search. Before knowing what is a state space search, first you need to understand what is mean by problem solving means. I given a problem to you. Our aim is you need to generate the solution. Yes. Now, problem solving means simply the process of generating the solution from the given data, that is from the observed data. And remember, while generating the solution, first you need to characterize the problem with a set of goals. That means whenever you are reaching this point, then only we are getting the solution. Meanwhile, set of objects that are included while generating the solution, what are the different operations that we are performing. If you want clearly, the once you are solving a problem means you are finding the solution. So to build a solution for the problem, the first step is you need to define the problem clearly. Means clearly define the problem. Once you clearly define the problem, analyze the problem, that is understand and analyze the problem carefully. Once the analysis is completed, then you need to identify the knowledge that is required for solving the problem. So which domain or which topics are needed for solving a problem? Once the identification is completed, among your identification, select the best technique for solving a problem. You got the point? For solving a problem, you need to do all these steps. Now, why all these steps are important to state space search? Remember, what is mean by state space search? This is simply a problem solving approach. You got it? State space search is a problem solving approach. A problem solving approach where we are exploring different states of a system. Remember this definition to find a solution. What is your aim? You need to identify the solution. For identifying the solution for the given problem, you need to explore different states of a system. This is called state space search. Now we will move in detail. A set of all possible states for a given problem is known as state space of the problem. That means I given one problem to you. For that, we have multiple number of states, different possible states, entirely clubbed together. That is called state space. Whenever you have a state space, you need to remember some important terms. What are the first two terms? State. So here only the concept, set of possible state. What is mean by state? State means simply a specific configuration of a system, specific configuration of the problem. That means right now I am in which position. Okay. Once you are identify the specific configuration, any problem solving approach starts from initial state. Now, what is the meaning of initial state? The starting point of the search process. The starting point of the search process. Immediately, you need to know one more term. Goal state means this is the desired or required end configuration. These are the main three terms related to state. Now, we are moving from one state. For example, initial state is S1. I am moving from state 1 to state 2 and state 2 to state 3. So, this is called transition, means an action that changes from one state to another state. Suppose on state 1, if you are applying some operator, we are transition to some another state. And one more thing is their path. What is the meaning? So S1, S2, S3, this is called path. Simply a sequence of states that are connected by the transition is called path. These are the important terms that are related to state space search. Now, a problem consists of state space. What is the state space? All possible states start state and goal state. And already completed. What are the meanings of all this? A solution to the search problem is a sequence of actions. That is, right now I am in state 1. Here I am doing some action. Based on the action, I am moving to state 2. Suppose here I am doing some action. Based on the action, assume I am moving to state 3. Okay, like this, we are moving some transitions, finally reach the end state. Now you got it. The state space search means simply for the given problem, multiple states are available. By using the states, we are reaching the goal state by moving with different transitions. Anyway, here you are using the search problem, that is searching the solution. Now, the search algorithms are divided into two types. One is uniformed search and another one is informed search. One is uninformed search and another one is informed search. Remember, this uninformed search is also called as blind search. What is the meaning? Suppose right now I am at this stage. This is my goal state. How to reach the goal state? Here I am does not follow any logic. Suppose if you are using BFS, I am traversing all the nodes. And after that, I am traversing all the nodes at next level. Blind approach like DFS, BFS, UC search. So in informed search, here you are using some heuristic function. Here using some heuristic function to reach the goal node. That means instead of exploring all the nodes in the blind search, in informed search, we are exploring only the nodes based on the heuristic function. Now, in this chapter, first we are discussing DFS, BFS, some blind approaches. Once you understand these blind approaches, next we are moving into the heuristic approaches. Clear? Now, applications where we are using state space. Anyway, the common examples, path finding. Path finding in the sense, if you are moving from one place to another place, suppose GPS, in that we are using this state space. That means right now I am at this place. This is the goal. For reaching start state to goal state, multiple paths are available. So from this to this, this to this, this to this. So for path finding, like puzzle solving, Sudoku, 8 puzzles, 4 puzzles, and in gaming also we are using like checkers games. That means at one position I have multiple paths are there. Which one you are selected? Which one you are selected? Planning means suppose scheduling the task. Automated scheduling of tasks. Suppose if you are using robotics, so at this time this robotic wants to do this operation, and natural language processing you are using, and theorem proving is simply the logical proofs. Okay, in all these situations we are using state space search. Anyway, the last, what are the challenges that are faced? First one is complexity, means we are at start node, we are exploring multiple number of nodes, and at this stage again exploring multiple numbers. So high branching factors, automatically the exponential growth of states increased. Resource limitation, if you are exploring more number of nodes, the memory requirement is a very and processing power is also reduced. And one more thing, suppose if you are using heuristic, that is informed search, selection of heuristic function also plays very crucial role. These are the challenges that are faced by the state space search. That's the end of state space search. Thank you.